check that out. Okay, so code coverage. Code coverage, who's heard the term before? Has your tutor mentioned it to you? Nothing? All right. It's a term that can be thrown around a bit. To some extent, its name might help you understand what it's about. Code coverage, like how much of your code do you cover? What does covering it mean? You know, is it like looking at it, like not too sure? What we mean by code coverage, though, in the context of this course, is it's all to do with testing. In particular, it's a topic about how do we check how much of your code that you write, your implementation, is covered by the tests. It's an idea you probably, have an intuitive understanding of, right? Like you write tests with the idea that you want them to cover the code you've written or will write. That's why we write tests. If you write a bunch of tests that don't test the actual code you end up writing, you wouldn't consider them good tests. So I don't think I need to explain to you the importance of code coverage, because having a test that covers a lot of code is a good thing. The part of this lecture that's relevant is that we need a mechanism to test how our code is covered by the test, basically. Because it's not really about, you can look at it, but we need like an automated, mechanical, systematic way to actually check that. Now we're going to talk about coverage in general, a little bit of a high level, but then we're mostly going to talk about code coverage and also coverage in Jest. So firstly, coverage, it's a measure of how thorough our tests are. Makes sense. If our tests cover a lot of code, our tests have good coverage, and therefore our tests are thorough. One important distinction here is test coverage and code coverage. So this lecture is on code coverage, but there's another term called test coverage. And test coverage is a measure of how much of the feature set of things is covered with tests. This is often led by human discretion, human judgment. And this is actually probably how you've approached testing and implementations back in iteration 1 and even 2, is that you say, well, we've got to test auth, like register and log in and creating a quiz and that, right? You think about it at a very block level, high level. You're kind of seeing what your tests cover, right? So think of that one as like high level, a bit more qualitative. A human can mostly do it. It's how your tutors actually look at probably your code when they read it, right? They look at your tests and they go, yeah, I can see a test for this and a test for this and a test for that. Whereas code coverage is a measure of how much code is executed whilst the testing is being run, and this can be computed and quantified. So this is a quantitative approach, this one here. Now, code coverage, typically what it does is it measures code coverage as a percentage of lines executed. So you imagine that your implementation, get all your implementation files, auth.ts, quiz.ts, you stack them all up and they might be like, I have no idea, 600 lines of code, right? No sense of how big it is. If your tests, whilst running, execute 500 of those 600 lines of code, then you would express your code coverage as 5 out of 6 or what's that, 83%, something like that. You would say like, oh, it's 83% covered, right? That's the quality of our code coverage. And it's a great way to give us a good indication of how much of our code is executed. It helps you really understand, because if you see code that your tests don't ever execute, that's kind of code that's in your blind spot, right? That's code that maybe there's a bug in there and your tests would never find it out. So it really helps identify where code isn't done. It doesn't really help us figure out where we've written too many tests or unnecessary tests, because once you've checked all of your implementation, it's just 100. So if you get 100% code coverage and then you double the amount of tests you have, it's still going to be 100%. So it's really about where you undercook your tests, not really overcook it. So it's all about that undercooking element. One of the cool things about code coverage in JavaScript, and it's actually really great and easy, is that it's actually really easy to do. It's a little harder with servers. There's some code we give you for iteration 3 to kind of do coverage with servers, but this lecture is just on simple JavaScript stuff. So imagine, think like iteration 1 before we did HTTP. But it's really easy with Jest, because Jest actually has a code coverage capability built into it, where we simply have to add a flag to Jest and it will give us some coverage information. So what I've got here is we've seen this piece of code before, right? I don't know if I was the one teaching you for it. I'm sure it was Yuchao. Is leap year, takes in a year. You got all the classic leap year rules, very confusing, very strange. And it returns a result. Okay, sure. It's a great little example of a piece of code to test code coverage on because there's a lot of branching. There's a lot of if statements, else statements, and stuff like that. So, and we've also got this piece of code here. Now, what we're going to do, just make sure I'm not too far ahead. Yeah, so we're going to run Jest coverage to run the test. So what I've got is I've got our code up here. I've got is leap year and I've got data year here. And in my package.json, you can see that I've got Jest here. So what we're going to do is we're going to try and write our own little test for this and modify it as well. I'm going to go grab a test back from week, whenever we did testing. Yeah, I'll just grab like a bit of code here. So a bit of live stuff today, lots of fun. We'll call this like, we'll do it is leap year test. So I make it is leap year.test.ts like this. And you know what we'll do is we'll import our function. So inside is leap year, we've got our is leap year function. So we'll import that from is leap year. Cool. Now, again, just my friendly reminders when I program and stuff. I like to never, if I can, write much code that's complicated at the start. I usually like to write really simple code like this. And I will go and run that code, just my kind of usual life tip. So that's the Jest I'm going to run. It's not testing anything, right? But I don't even know if I've written the Jest properly, right? We don't write Jest every single day of the week. So I'm simply going to bring that up on the command line here. I'll go inside my today's lecture. I have to npm install this one, so give it a sec. Shouldn't be too complicated because there's not too much to install. Is anyone getting sick of the rain yet? I'm getting sick of the rain. npm run Jest should work hopefully on is leap year .test.ts. Let's have screwed something up. OK, all tests passed, right? Of course, because we didn't do anything. But at least I know my code runs now. So I haven't screwed up any of the infrastructure. So now what we can do is we can, well, simply call well, I expect that if I call is leap year on, say, the year 2000, that it should be a leap year. Make sense? Who was born after 2000 here? Damn, okay. That's not good. All right, well, 2000. I want to pick one you remember. Remember 2008? Remember that leap year? Yeah. I don't think you're that young. It's okay, 2008's a leap year, cool. Now, we get that, we get Jest, but here's where things get more interesting. Obviously, if I go back to my package.json here, in this case, when I write Jest, it's going to run the Jest command. Okay, but if I add a -- coverage here to the Jest command, when I run this now, because remember, npm run Jest looks up the script Jest, I get more output. In particular, I get this little breakdown here, which is quite interesting, where it says, OK, well, here are all the files that I did the coverage checking on. In particular, it's gonna basically stack up all the, like if this makes sense, you've got tests you run, and they go across all of your implementation files. And what Jest coverage will do is look at all those implementation files, count up all the lines that the tests you run touched when it did the testing, and just write you a little report here. We only have one file in this case, which is isleapyear.ts. And what we do with that is we see, OK, 50% of the statements were executed. In particular, the lines that weren't covered was lines 3 and lines 6 to 9. So if I open up this file here, it's saying, hey, we didn't touch this line here, and we also didn't touch lines 6 to 9 either. So it's kind of telling us which lines our test did not touch. It does say that we touched 100% of the functions. That's obvious, because there's only one function in this file. If I wrote another function called blah, that did nothing except console log blah, you would see that if I ran this again, you would see a different result. You would see now only 50% of the functions were touched by the tests, as opposed to 100% of the functions. If I added a whole other file to this folder called blah, which simply exported another function called blah, that console logged blah, you'll see when I run this now, we're going to have another file. Oh, should have. OK, sorry, it only shows the files we touch. But I think if we import it, Let me just double check I've got my understanding right here. Okay, probably have to actually execute something. That's okay. Don't worry about the other file. If you've got more files, kind of everything that gets imported, because it kind of starts out from where the tests are going. So you see in this case, only half the functions, half the statements, and we've got these uncovered lines. Well, we kind of get the functions part, so let's not distract ourselves with this. Now, sure, what you can do is you can look at those uncovered lines here, and you can track that down. However, another thing you can do, and we mentioned this in the slides for you, is that when you run this coverage command, there is a folder that should be created here, which you'll see called coverage. So you see this folder called coverage. That folder, if I go inside of it, we'll have another folder called lcov report, which will there have a bunch of stuff. I don't know if I can open up. Can I open up Chrome from the terminal? It's all good, guys. Sorry, let me just grab this real quick. So if I go to like 1.5, yep, and then I go to this folder. So you can do this in your own like Explorer, right? Whether you're on Windows or Mac. You go find that file here, this index.html. You grab it and you simply drag it up here. And what this file does is this file is it's a web page that's generated by the coverage command. And what it does is it goes and gives you a bit more of a graphical summary of things, which can be really useful. So for instance, here I click on is leap year, and now it actually shows me where the code didn't execute. So it shows that, yep, line 3 didn't execute, and these lines didn't execute, and that line didn't execute. Yeah.
Have like a TypeScript interface for something that doesn't actually execute. Is that just going to account for that?
Yes, I don't know how though. I don't know if it like ignores it outright. I'm not sure if it just transpiles it, then runs the JavaScript, or I'm not sure if it executes it once it infers the type. If that makes sense. Like if you, for instance, if you have a function again called blah, and imagine that blah has a type called some type x equals int or string, right? And then here you say, yep, b is type x. I'm not sure if it just ignores that type or if it covers it when the function is called because it had to infer the type. But because TypeScript's statically compiled, right, by the time Jest would ever run something, TypeScript's already checked it. So I more likely imagine it just ignores it because like if it's kind of TypeScript, if it's made it to the Jest point, then the TypeScript's valid and it doesn't really matter too much. But, yeah. Yep.
What about functions that are not exported? Like just functions inside the file which you don't.
What about functions that aren't exported? What about, that are just in the file? Well, they should be covered because other functions in that file are calling them, right? So if you have a helper, it's a great question. Like if you have a helper function up here called blah, then at some point in that function, if it's not exported, you would imagine that some other function is calling it. So that if it's Jest will cover it because it covers this is leap year. So when it calls like one function like is leap year, your other functions will call the helper functions, if that makes sense. Obviously, if you have a function in your code that isn't exported and no one uses it, it's a literal unused function, then it will come up as like uncovered, right? Because no one's covered it. Usually, like in a course this small, we'd probably say like if you have a function that's never used by anything, you should just get rid of it. In the real world, that happens, that there might be an unused function. Maybe it's something that they've commented out, for instance, and they want to leave it there for like a week while they test something. In those cases, and I don't know what it is for Jest, but there's usually kind of comment signifiers you can leave, like, Jest, if you do something like this, Jest coverage ignored, that's not what it would be, but usually Jest will have these things where it knows how to ignore certain, like the linting as well, for sure. It's a great question. So why this is useful, and you don't have to do this in iteration 2. There's no marks for like code coverage in iteration 2. There are marks for test coverage, right? Your tutor looks and says, does it look like your tests roughly check in all the routes? It's very high level. It's something you could do too. But there's no numerical analysis that you get really any aggressive marking on in iteration 2, but in iteration 3 there is. So if you're in iteration 3, right, imagine we start iteration 3 next week. The first thing your group might do is run code coverage. And you find out that your code is like 92% covered. OK, well, now you go and figure out what other tests you have to write. So in this case, imagine that you're writing these tests and you're like, oh my God, oh, it's not working. Oh, OK, we've got problems here. So what do? You reason with it. You think, well, OK, if year is not divisible by 4, so you think, OK, well, we simply have no, I mean, you would figure this out pretty quick. We simply have no case of like 2003 or something. Now, naturally, you'd probably break these up into their own tests, just to be clear. You'd have like, tests for like, divisible by 100 and divisible by 400 and like odd numbers and stuff. I'm just writing it in one block here, but you would probably break it up. And then you go and add your extra test, and then you simply come back to this, the folder. I go and run my coverage again. OK, now I can see that the coverage is up to 62.5%. That's better than 50%. And if I just go back to my web page, you don't need to find it in your browser, in your Explorer again, because all the coverage tool has done is just regenerated that page. So I can just hit refresh on this page now, right? You can just leave that up in the browser and keep hitting refresh. And I think, oh, cool, OK, I've done another one. What's the other case here? I've got a case where the years... what is that? If the year is not divisible by 100. OK, we've covered that case. If it's not divisible by 4, sure. But we haven't covered the case where it's not divisible by 400. So what that means is like 2008 is divisible by 4, but it's not divisible by 100. So that's where that got covered. The next one could be if we're not, what is it? If it's divisible by 400. So we might need to do the year 2000. So we can try that one again too. Cool, we're at 87%. We've kind of covered more. And then we need one where it's like, what is that? It's like not divisible by 4, or it is divisible. Stuff's so confusing to me. What is that? So it is divisible by 4, is divisible by 100, but not divisible by 400. So what that means is, and hopefully many of you live to this year, 2100. 2100 is not a leap year. Right? Because it's basically every 4 years is a leap year unless it's divisible by 100. Then it's not a leap year. Unless it's divisible by 400, then it is a leap year. So that one should now not be a leap year. So now we can do false there, and we can run this, and we get 100%. Everything's 100%. Now here's an important distinction. Imagine I write my test wrong, because 2100 should not be a leap year. But let's imagine I do an expect that it is, and then I run my code again. Well, what's going to happen now is that we fail our test, but we have 100% test coverage, code coverage, sorry. And that's an important distinction to make, because like code coverage is a measure of how much of your code is touched. It has nothing to do with how successful your tests are. And all this tells us now is that our tests do look at all the code. This doesn't mean that your code is bug-free or anything, but it does mean that your tests have tried to explore every part of the code, which is a great measure generally for it's a proxy measure for the quality of your tests. What you'll also notice here is this one called branch. Lines and statements are pretty much the same. The distinction there is like, I haven't really ever explained this in a lecture. Let me see if I've got this right here. Oh, it's the wrong thing. Usually what that means is, let's actually get rid of a couple of tests here. So let's just run that again. So let's say in this case we've got 62% lines and 62% statements, and the ones that we have missed are those 2 lines. So usually if I say bring that up there, I should get a different result. Yeah. So a statement, there's a programming language definition of what a statement is in programming, right? But lines is what you'd expect as lines. Generally, statements and lines should be the same number if you've written decent code. Like this is not very clean code here, bunching that all up. A statement's typically like a line that should be executed. So I'd say don't overthink that part. Like statements and lines are generally the same thing if you've written good code, because each statement should be on its own line. Functions you get. Branches are slightly more interesting. Branches is a measure of, and we talk about this more in the slides, but I'll jump ahead. your code can be broken down by basically a series of like while loops, for loops, if statements, else statements, right? And what I mean by that is if I go and put like a console log here, say I put like a bunch of console logs. See how the last results were that we covered 63% of statements and 50% of branches. If I now run this again, what you'll see is that we've still only covered 50% of branches, but we've covered 20% of statements. The reason for that's kind of obvious. It's because this is never, well, I mean, that's not, I should put that on the other side. I kind of meant to flip those around. So if we come back here, 63% of statements, 50% of branches, I run it again, and then what I get is 87% of statements and 50% of branches, right? So just by adding more lines of code, my statement percentage has gone way up, but my branches one stayed the same. That's because branches is a measure of how many if-else statements, how many different kind of like scenarios do you have through this function, right? Because obviously when you enter this function, you're always going to go through the console logs every time. But then you've got this if statement and else, if, else, if, else. So you've essentially got 4 ways through that function. It doesn't matter how many lines of code there are between the function and the branching, there's only 4 ways through the function. Now, the reason that sometimes branch coverage is a really great measure is because branch coverage is somewhat static to an increase in the number of lines of code. And what I mean by that is if I have a lot of code there and I run this again, you could be like, oh my God, I'm like 97% covered. Great, you know, like good on me. But you've actually haven't explored half of the possibilities of what this function can do. You know, so branching coverage is quite important because it generally denotes risk a lot better. Because there's not really going to be much risk in like one line after another, because typically all the branching you do covers all those same lines anyway. So branching coverage is super valuable in a general context. Here's the catch of it though. The way, and again, I think we'll probably get someone to review this for next term, but the way that Jest coverage works is there's some strange quirks with it to do with branching. We experimented with this a couple years ago, and we found out that Jest branch had just some, like without going into it, some oddities. So whilst branch coverage is actually a really great measure, in this course we do statement coverage. So that was more like me teaching, like this is like a broader idea you should aim for. But in 1531 for weeks 8, 9, and 10, a very short space of your life, we'll be looking at statement coverage. Just because it's easier to test. And generally also, no one really has fat functions that have like, in this course, no one's got functions that have like 30 lines of code that don't have if, else, or while loops in them generally, you know? There's like if statements and else statements everywhere.
Does that mean it's not like unreasonable that you won't hit 100% statement coverage though? Like in our tests for iteration 3, like is 90 okay? Or do you want to go for 100?
Yeah, like so, I mean, we'll talk about it next week, but generally speaking, you know how like in iteration 2, it's like your tests times by our tests. That's like your result, right? Plus linting, but let's forget about linting. That's your like auto mark result. In iteration 3, what we do is we then multiply that by coverage cubed, and basically coverage is a score between, call it like 0 and 1, right? And you might have like 0.88, 0.92. But the thing is, like, even those of you who've written really poor tests, your coverage is probably still at like 80%, because one test will typically go through a lot of the function anyway, right? So the reason we do that is because like generally, and I'm just pulling numbers up here, but 70% coverage is like pretty bad, pretty poor effort, because you don't need many tests to get good statement coverage in your code. And then like 80% coverage is like okay, 90% coverage is like, yeah, doing good-ish. 95% is like, yeah, good. 98% is like pretty good. And then 100% is like, perfect kind of thing. And the point is that this is maybe a poor explanation, but going from like 70 to 90 is easier than going from like 90 to 100. Just because getting those last niggly bits, like I don't know if, I'm not a mathematician, but it's got that like logarithmic feeling to it, right? Where it's like, it's hard, it's more and more effort to get down to those last bits. So because of that, what we end up doing is we actually cube your coverage score in iteration 3. And what that means is like if you say get like, and I can do this in the browser a bit easier, is if you get like 0.7, your actual coverage mark is 34%. Whereas if you get like 0.8, your coverage mark is 50%, and 0.9, your coverage mark 73%, and 0.95, your coverage mark's 85%, and 0.98, it's 95%, and 1 is 100%. So the cube element there kind of actually correlates your coverage number to effort, if that makes sense. Because it's so easy to get to 70, and then kind of exponentially harder to get towards the end. But your question, who'd ask the question? Yeah, okay. Your question was about, do we aim for 100%? It's like, yeah, you want to aim for 100%. Though there are lines you can ignore coverage on if you need to. Because some lines just, depending on some implementation students have, sometimes there's like a random function that they needed to add that never gets called. And it's just not giving you 100%. So if you talk to tutors, tutors are allowed to like endorse you to exclude certain functions or lines from coverage if you feel like it's impossible. They can just approve the comment being added in. Because I think this is an important note too, is that the auto marker, we don't really mention this, but the auto marker will trawl your code for any git ignore lines or TypeScript ignore lines or coverage ignore lines and stuff. And it does get flagged with your tutor. So for instance, let's say there's going to be one group in iteration 2 in the course that puts a bunch of linting ignore lines in somewhere, or they put that little thing at the top of the file, with ESLint where you can ignore the whole file. Has anyone ever seen that? Don't look for it. It's fine. They look for that too, so there'd be a similar thing with coverage. And then your tutor's like, oh yeah, I okayed that, or they're like, no, I didn't okay that. Bit of a rambly answer, but. We talked about branch coverage. We don't do branch coverage in this course, but keep an eye out for it after the course. We'd love to do it in this course. Okay, so summary is code coverage is useful. It's more important to look at what's not covered than the coverage percentage. Yeah, that's true. Obviously, from an auto marking perspective in iteration 3, we do look at the coverage percentage. But what we're trying to say there is that, if someone said to you, oh, our code's 85% covered in general, you would typically be like, well, what's not covered, Because again, 1531, tiny project. I know the project feels big because, it's 10 weeks and it's like the most of the course, but grand scheme of things, your project's a pretty small piece of code. If you're working on a very large code base in a corporate, the point there is that there's certain code that can break and there's certain code that can't break. Like a good example is that, say like the startup I run, we have pieces of code. Like we hold many millions of dollars of people's money, right? And as part of that, we have to make sure that our systems that tally that up and subtract it and manage the deposits and withdrawals, that they work okay. We need to make sure that code works. So if you were, say, looking at code coverage of that, you would go, if that is only 90% covered, that would be a big deal because you've got 10% of this critical system that's not covered. So that matters a lot. Whereas if you've got some random thing over here, some random web page, like some contact us page that you've built, and someone hasn't tested it super thoroughly, and the coverage is 70%, the coverage is 70%. You would say that the 90% on a critical system is way worse a situation than the 70% on an uncritical system. Again, everything in your project is small enough that you couldn't really discern critical from non-critical systems, but the point of that line is that bigger picture stuff, don't just be like, oh, it's a percentage. Actually dig into like, what is this? How critical is it? What could go wrong with it? Any questions?
So outside of this, branch coverage is generally more as opposed to statement?
Yes, yeah. They're both, you could argue that they're both important. But it's more like if you really pay attention to code, errors happen typically from loops not being entered by a test, or if statements or else statements. It's typically like the path not followed, that the input you wrote in your test never went into a particular whole chunk of the code. And where it gets really, actually a good example, thanks for asking the follow-up, is sometimes you can have code like this that's like, if A, then do B, C, D, E, F, G, else do H, right? And if you only ever pass an input that is truthy for A, you'll like never see this whole other half. You know, and maybe in reality, this is actually like what a user ends up in 50% of the time. But if you look at just statement coverage is going to think you're like 90% covered because you like got through all these lines here. But yeah, so that's mostly what it's relevant for, because bugs will happen on the lack of branching that you check. Cool. All right. Well, let's take a